All right, guys. So the next lesson is on uh, is actually a continuation of the same section in the textbook, 5.2, but I broke it up into two pieces. So the second part of this lesson, 5.2, properties of functions, is called something called function notation. And this lesson itself, it's actually very important to get a handle of this because function notation will continually show up. As you work through your math career experience. It shows up a lot in pre-calc 11 as well as pre-calc 12. So we need a very firm understanding of this concept. All right. All right. So far we have seen relations and functions. Right? So remember, functions is a type of relation. Right? So all functions are relations. Uh, However, all relations are not functions. It's just a subgroup of relations. So anyways, we've seen relations and functions expressed in tables, arrow diagrams, and graphs. Okay, so that's from the previous two lessons. So these are some of the ways that we can express a function or a relation. Right? However, as well, functions can also be written in the form of an equation. All right, so that's what we're going to be looking at today is when functions are actually equations. And in general, right, you will actually be seeing functions as equations for the most part, right, from now on. All right, so what we're going to do here is just kind of jump right into the first example. And I'm going to take my time here just trying to explain the concept of equations as functions. All right. So for the first example, right, the equation V equals negative 0.08 d plus 50, right, represents the volume, V liters. Okay, so that's V over here, of gas remaining in a vehicle's tank after traveling d kilometers. So there's two things happening here. Right? If we know how far the car has traveled, then we know what the volume is left in the tank, right, using this equation. All right, so the gas tank is not refilled until it is empty. That's kind of obvious for this equation to work. All right, so first one here is you want to write the equation in function notation. All right, now before I do that, actually, I'm just going to give you the kind of a rundown or a concept of how these equations work as functions. All right, so in this case, right, what we have here is we have two variables. Right? And variables are when there's letters representing kind of numbers, right? Variables, we can plug in numbers for D, and we can also plug in numbers for V, actually. Right? But anyways, those are variables. Now there's first thing we need to do is we need to be able to um, distinguish which one is what we call the independent variable and which one's the dependent variable. And write those two over here. The independent variable and dependent variable. That's either an E or an A. I forget how to spell it. But anyways, independent, dependent variable. All right, so in other words, this is what I'm going to put as my input into the function, and this will be my output. Okay, now the reason for that is the independent variables, these variables or these numbers don't depend on anything. Right? We're just kind of picking those numbers at random as an input. And then what happens is what you can envision is like the function itself is kind of like a machine. Right? So here I got V equals negative 0.08 D plus 50. All right. Actually, you know what? Let's use a different color here. All right. So in red here, this is what you can kind of think of a function as an equation as kind of like a machine, right? So it kind of converts. So what ends up happening is the third color. All right. So what ends up happening is we have a number that gets plugged in the machine, and then it outputs a different number. All right. So this is called your independent variable is your input. Right? This is actually also refers to as your domain. So if you guys remember that from last lesson, the domain is like the first set, right? And then the range, which is the second set. These numbers over here will be dependent on, so that's why it's a dependent variable. Well, depending on what number you plug in here to the domain. All right, so let's say, for example, use it kind of like an easy number. Let's say I take the number 100. So this is actually going to be D. So the reason it's D is because it's on this side of the equation. Basically, I'm going to plug it in here. And what will end up happening is this, once I work this part out, it will give me a value for V. So to do that, I'm going to go V equals, actually, let's use a different color. All right, so over here, let's go with red. I've got V equals negative 0.08. Then what I'm going to do here is plug in 100 into the variable D. And I'm just going to see what number actually comes out. So here I've got V equals, all right, so negative 0.08 times 100 is negative 8 plus 50. So V is going to equal 42. All right, so what does that mean? That means that when you've driven 100 kilometers, right, because I plugged in D, the distance, 100 kilometers, so D is in kilometers. I plug it into this equation, it gives me a V of 42. So that means I have 42 liters left. So, so we'll go with, obviously, this. This is kilometers. Okay, so so there's, yeah, so in terms of conceptually, this equation here gives you the volume if you know how far you've driven. Right? That makes sense, right? You just plug that at 100 in for D, and it spits out a value of 42 for V. Okay, so you can kind of view functions when they're written as equations. It's kind of like a machine where it converts one number into another, right? And that's basically what a relation is, right? And a function. All right, so yeah, quite a bit of theory being thrown at you right now. All right, but hopefully that makes sense. All right. So the independent variable is basically the number you plug in. The dependent variable is the one that comes out. Right? So the independent variable is always your input. Dependent variable is always your output. Domain again is the numbers that can be plugged in, or the numbers you plug in, and the range is the ones that come out. Right? So that's why this one's dependent, that one's independent. All right. So when it comes to this new kind of concept where it says function notation. So let's all right. So when it comes to function notation, right, what it's asking you to do is write the equation in function notation. All right. So this may look a little funky, but so basically this equation here, V equals negative 0.08 D plus 50. When I want to write this in function notation, it's just basically what you do here is you just add in a bracket. So V and then a bracket D equals negative 0.08 D plus 50. Okay, so yeah, just a slight difference. So after the V, you just put a bracket of the dependent, or yeah, the independent variable. Right? Now this is red. So when you read it, you'll hear me say V of E. All right. So so yeah, so basically what that means is that we want to find the volume of this distance, and to do that we use this equation. So essentially what we did up here, yeah, so this would be using this value here is D. This value here would be V of 100. So So anyways, the volume at 100 kilometers is 42 liters. That's how it's kind of rendered. That's the concept. Okay, so this function notation, what you'll see is like brackets, right? A variable with a bracket. And so, yeah, basically you're using the equation to get that value. All right, so hopefully that kind of makes sense. All right, so for part B, you want to determine the value of V of 600. Right, what does this number represent? All right, so V of 600, so that's what this is red. So basically what I'm going to do here is, so V of 600, I'm going to actually just, you know what, I'm going to use a different color number here. So V of 600, so you guys can kind of see what's going on more clearly maybe. All right, so this is going to equal negative 0.08. Then for the D here, I'm going to plug in 600. And then plus 50. All right, so V of 600 equals, all right, so this here, negative 0.08 times 600. Try to do this in my head. I believe that's negative 48. It's 50. So V of 600 equals positive 2. All right, so that means that the volume at 600 kilometers is going to equal 2 liters. Right? Now, this is, you actually stop here. Okay, so what I've noticed sometimes when so this is an error, right? Wrong to continue. All right, so what I mean by that is that you see this V of 600 equals 2. Some of you may accidentally think that this means the volume times 600, right? Because you see brackets, you're used to seeing like, you know, the two numbers when they have, you know, them next to brackets, you know that means to multiply them, right? This is true, right? But once you get to this point, you stop, right? Do not divide both sides by 600. I think that V is equal to 1 over 300. So that is wrong. Okay, so what you want to do when it comes to function notation, this is your final step. Right? So that is your answer. Stop there. Okay. Do not continue on. All right. So yeah. So the volume here is it's going to be 2 liters at 600 kilometers. Right, now I'm going to just, I'm not going to lie, guys. I'm just going to double check this number here. So 0.08 negative times 600 equals that plus 50. Yeah. So it is going to be 2. All right. So the second part here, what does this number represent? Okay, so this means that we will have 2 liters of gas at 600 kilometers driven. All right. Okay, so that's how you would interpret that. Cool. All right, part C. Now it says determine the value of D when V of D equals 26. What does this number represent? All right, so let's just kind of first off write out the function itself. So V of D equals negative 0.08 D plus, I think it was 50. Try to get that right. Yep. All right, so this time we want to find the value of D. So we want to figure out what this value here is when V of D is equal to 26. All right, so this means that this left-hand side, V of D, what we can do here is replace it with 26. Because we want to find the value of D. And what would we have here? We have an equation. Okay, so we have an equation to solve. So that's why we spent some time on in the Math Mind review, right? Going over how to solve equations. All right, so hopefully you can solve these, right? So in order to solve it, first step here I'm going to do is move the 50 over to this side. That's minus 50. So over here I got negative 24, right, equals negative 0.08 d. Next up, what I'm going to do if I want to solve for d is I'm going to divide both sides by negative 0.08 so that these cancel. And over here, I get d equals. All right, let's punch that one in. All right, so yeah, so I'm just going to punch in 24 divided by 0.08. All right, the reason I didn't write the negatives is because these two negatives we know should cancel each other out, right? So it's the same as divided by 2 positive. All right, so I get 300. So d equals, when I solve it, 300. All right. So to answer the second part of this question, what does this number represent? All right, this means that when we travel, no, sorry, let me rewrite that. Please forgive me. Let's try this again. Okay, so V of D is 26. All right, so when the volume is 26 liters, that means that we have traveled 300 kilometers. Okay, so that's what that means, right? V of D equals 26. So when the volume is 26, we have traveled 300 kilometers. Distance is 300. Cool. All right, so this is just the other way, like plugging this into the other side of the equation to solve it. Cool. So hopefully that makes sense. Now this was a application. I thought it was the best way to initially show you this kind of concept. It's best way to actually show it is through a real life example application. However, what we also need to get used to is when there is no application. All right, so this is a little bit more abstract, but still the idea is still the same. All right, so you will see a lot of equation just given to you, and they won't tell you what it's all about. They'll just say f of x equals blah, 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 and they'll find the following. All right, so we're going to do that. All right, so for this next example, f of x equals negative 2x plus 3, and we would determine the following. All right, so we first one here, we want to find f of 3. All right, so again, this is red f of 3. All right, so the letter itself, f, traditionally it's f because they use the word function. All right, so you'll see f of x a lot, but you may see like g of x, t of n, and stuff like that. These two letters, traditionally it's f and x, but you could see a whole bunch of different labels. All right, but you're doing the same thing no matter what. So it doesn't matter what the letters are. The overall concept is still the same. Okay, so f of 3. So if I want to figure out what f of 3 is, what I'm going to do here is in the x here, I'm going to plug in 3. You know what? Then I'm going to go back to using different colors here. Probably a little easier to see what's going on. All right, so f of 3 equals the value when you plug in 3 in for the x. Right? So I work this out. Negative 2 times 3 is negative 6. Plus 3. This is going to equal negative 3. Okay, so, and I could keep writing f of 3 down here. And again, we are done here. Okay, you're not going to divide both sides by 3. But finish when it says you get to this point when you just get a number on this side. Okay, because this is not saying f times 3. This is f of 3. Right, so the value of the function when your x is 3 is going to. All right, cool. Let's try the other one here. Next one here. So f of 0 this time equals negative 2 times 0 plus 3. All right, so f of 0 equals, so negative 2 times 0 is 0 plus 3. So f of 0 equals 3. And again, we're done there. All right, you're not going to divide both sides by 0. You're finished. All right, so the value of the function when x is 0 is equal to 3. All right, and I thought I'd throw in a -1 as well. All right, so this time I'm going to do this fairly quickly, so I'm not going to change the colors here. All right, so I got -2 times -2 plus 3. So f of -2 equals, all right, so -2 times -2 is +4. So +4 plus 3. So f of -2 is equal to 7. And we are done. All right. Now, one thing I want to point out is that you will see f of x a lot. And traditionally, the input and output variables, right, are x and actually y, right? Because when you go back to like when you're graphing things, there was always an x coordinate and y coordinate. All right, so all that being said, basically what I'm trying to tell you right now is that f of x here, when it comes to like graphing functions, which you will be doing later on in this course, you can interchange this with y, right, in terms of when you're graphing it. So you just want to get trained in your head that f of x is the same as y. So once we move on to graphing these equations, sure, this is function notation, but this is also the same as saying y is going to equal negative. All right. So again, these are interchangeable. So f of anything is the same as the y variable, because traditionally the y variable is your output variable and x is your input variable. Right? Now, from time to time, they'll change the variables just to be, I don't know, creative or whatever. All right, but traditionally the input variable is always x and the output variable is always y. Right, so again, so these ones here, it's the same as saying y is equal to 3. So just in your head right now, lock that in. Just remember that f of x is the same as y. And that goes here, y equals 7. Cool. All right, so this is the last part of the example. All right, we want to find the value of x when f of x is equal to 11. So this is kind of similar to the last part C of the last example. All right, so what we're going to do here is, again, f of x is equal to -2x plus 3. All right, so this time, what I want to do is, it's saying f of x is equal to 11. So that means this side here is actually equal to 11. Right, and what I want to do here is I want to solve for x. All right, so to do that, we want to isolate x. The first thing I'm going to do here is to take the +3, move it over to this side. That becomes -3. All right, so then we get 11 minus 3, which is 8. 8 is going to equal -2x. And then to solve for x, I'm going to have to divide both sides by -2. Then these cancel, and we get x equals -4. Okay. So when x is -4, f of x is equal to 11. So you can also, and this is kind of extra, but I remember you guys get in the habit of checking. So if I was to figure out what f of -4 is, right, because that's my x, right, I should get +11. So I'm going to plug in -4 into the function here. F of -4 equals -2 times -4 is +8. 8 plus 3. F of -4 is equal to 11. Right? It's exactly where we started here. All right, cool, guys. So that's function notation. Again, very important concept to kind of get your head wrapped around. One of the common mistakes that I do see from time to time is, if I scroll back up, this right here, all right, not stopping, all right there. Okay, so again, do not get this confused with multiplication. This is just a label, right? So the value of the function when the independent variable is this number is equal to that. Right? Do not continue. Yeah, so this is function notation. Again, very, very important concept to get your head wrapped around for your future math career. All right, so that's it. Ciao.